All right, for the first talk, Jose de Pinapaz again, and I remind you for lightning talks, 3-minute timing. At 3.5, you get the gong. So.
Okay, this is Jose Pena again. We're going to talk about Windows native stack profiling. First, a definition. Coastal profiling. It's a performance analysis tool. It will performance. Oh, sorry, this way. It will sample periodically the call stacks of all the threads for specific workloads. Why? Because we want to understand better what is happening in the CPU and what is taking it, causing performance problems. How does it work? In compilation stage, we compile the functions and we get the address information where they are residing memory. In runtime stage, we do the same thing for functions compiled with JavaScript. And then the performance sampler is going to extract the call stack, and this way we can resolve the information. In Windows, we have Windows Performance Toolkit, and it's the system-wide tool provided by Microsoft for doing capturing of profiling information. And in V8, we support these two command line commands that allow to generate information for JIT functions to resolve the address. So recording, we use the Windows Performance Recorder or UI for ETW. And for analysis, we have the performance analysis that will mix all the information and show a nice representation. Okay, what we've been doing, we try to enable instrumentation by default in all targets, but we are not there yet because JIT generation or the information generation is heavy. On one side, we were generating the information for the built-ins. The built-ins were already compiled and were already in the debugging symbols of information, the debugging symbols of Chrome. So we didn't need to generate that. So now that's gone, that's fixed. There was another problem that we were generating for all the processes in the system, the information of JIT. Now we can filter that, so that information generated only on the process that need that. It's a work in progress, though. And third, for the interpreted frames, we have something that is a trampoline that generates address information that can be used in the call stacks. So now it's only set up when recorded, so we don't get that overhead when we are not recording a stack trace. Okay, these are the main contributors for last year. Yeah, my work has been sponsored by Bloomberg, and that QR has a link with a blog post where we talk more about this. Thank you.
Sit down. Let's see. I closed down as many of these windows as possible to make sure this was easy to find.
I think it should have the Igalia logo. Might have.
One would think. Yeah, there it is. There it is.
And then, okay, yeah, perfect.
All right, go for it.
Hi, everyone. I'm Max from Igalia's Chromium team, and this is a quick update on what we've been doing in Ozone Wayland. But actually, I want to start by giving a quick shout out to Lacrosse, which was a project to make Chrome on Chrome OS more stable using Wayland. It was started in 2020 and discontinued this July. And I just wanted to give a quick thanks for the 4 years where we had the chance to work on and improve Ozone Wayland. For those of you who don't know, Wayland is a display server protocol for Linux intending to replace X11, and Ozone Wayland is Chromium's layer for native Wayland support using the Ozone platform abstraction layer. It is still experimental, and you can enable it using one of the two command line flags on the side. The second one is also available using Chrome://flags. And even though it is still experimental, already 28% of the Linux users are using it, according to UMA histogram data. And I want to now highlight some new features we've gained. We now have IME in experimental status. So for example, for entering Korean, Japanese, or Chinese input. There are some edge cases we still have to resolve. And also we're not yet fully W3C spec compliant due to some issues on the Wayland protocol level, although a new protocol version is already in the works. Users have had success using it thus far, though, and we've gotten some quite positive community feedback, because previously we had almost no IME support on Wayland, and it was one of the main pain points of our users. And to try it out, you can use the flag shown on the slide. We also now have the option for full tap dragging UX as on all other platforms, as long as the XDG top level drag extension is implemented by the compositor, which currently is only the case for KDE Plasma, but we hope that other compositors will follow shortly. And also the Chromium support just landed. It's not reached stable yet, but it works perfectly fine. For the cases where we don't have this protocol extension available, we're still working on fallback tap dragging. We've fixed all the issues with interactive UI tests. We're ironing out the last 2 bugs, at least those that we know of. We are already dogfooding it to G-Linux users, and there have not been many bug reports, which I take as a good sign. It's also still not enabled by default for all the rest of our Linux users, but we should be able to do that soon. And in general, we hope to be able to enable Ozone Wayland by default for all our Linux users in a very short amount of time. Thank you.
Take my response. Oh, let me get to the right slide for you.
Thank you so much. So hello everyone, I'm Rezwan from VA JavaScript team, and recently we shipped some JS features to Chromium, and today I'm talking about Iterator helpers. There's a blog post on our website that you can check out for more explanation on them. So Iterator helpers are actually a collection of methods on Iterator prototype that help in general use of iterators. So all the examples in the blog post and also in this presentation, you can try them on our blog page. So let's get started. The first helper is map, which returns an iterator of values with the mapper function applied to the original iterator values. So for example, if you have a list of the blog posts in an archive page in an iterator, you can get the list of the text content or their titles in a new iterator and do something with it. We just log them here. So the next one is filter. This helper also returns an iterator of values from the original iterator for which the filter function returns true C value. So for example, you can filter blog posts that includes V8 in their title or text content. Take returns an iterator of values from the original iterator up to limit number, up to limit values. So you can select 10 recent blog posts from a list of the posts on our archive page. Drop returns an iterator of values from the original iterator, starting with the value after the limit value. So like you can drop 10 recent blog posts and create a new iterator from the rest of the iterator. ToArray obviously returns an array from the iterator values. For each is actually called for its side effect, and it returns undefined. So in this example, we have a list of the blog posts in an iterator, and by calling for each, we get the data of them, the date that they're published, and save them in a set, and we just log them here. So the for each is actually returned undefined here. Some helper returns true if at least one of the iterator values returns true when the function applied to it. Like you can find if any of the blog posts in our list includes V8 in their title, iterators in their title, this example. So there are more helpers. I don't have time to go through all of them, but you can check out our blog on our website. And at the end, I just want to mention that there's an upcoming JS feature, explicit resource management, that we will ship soon. And this feature added using and await using declaration, and also disposable stack and async disposable stack data structures. You can check their GitHub repository if you are interested to learn more about it. Yeah, thank you.
Yeah.
Hi everyone, and today I'll be giving a presentation on a new Blink DOM feature, which is to allow focus navigations for in visual order. So what is focus navigation? Focus navigation is a mechanism that allows you to visit the elements on a page and interact with it using a keyboard. This follows a focus order, which currently for all browsers is the DOM order, the order in which the elements are added into the page. So that may not always be the ideal focus order to go through because that may not always match the visual order. Because of different CSS layouts such as grid and layout, grid and flags, as well as different values such as direction, writing modes, the positions of the items will potentially change and not match the DOM order. So in this example, we have the items 1, 2, 3, 4 are added into using a grid template, and because of that, the item 4 is being presented first. And as you can see, the animations, the tab order will feel very unnatural as they follow 1, 2, 3, 4. So the CSS working group has been working on this for years and have come up with a solution of adding a new property, the reading flow, which is as described here. So the reading flow property controls the order in which elements in a flex or grid layout are rendered and are navigated when using linear sequential navigation methods. So there's a specific set of values such as normal, flex visual, flex flow, grid rows, grid columns, and grid order. And given that specific value, it will say it will affect the focus order of that will be followed. So there are, as I'm implementing this in Blink, there are a few technical challenges, and here I'm describing how we kind of fix that. So first, there is no other kind of project currently that is trying to surface the layout order to the focus. So what we did here is we went in the code for the flex and layout and grid layout algorithm and modified that, so that we can sort the elements accordingly and save that in the layout order, which can then be surfaced up. Second, the technical challenge of how do we modify the focus navigation code. For this, we are going to, let's say, how it's defining the HTML standards, as well as defining how what is a focus scope owner, and having the reading flow be its own focus owner. Challenge 3, what do we do about elements that may not fall inside a layout container? In this case, we actually do have a few proposals. This is still being defined. And another challenge is how would this new property interact with existing other features such as the tab index. This is also defined. We are considering how we can potentially ignore this when inside the grid or flex container. So currently, there is a prototype and it is working. So as you can see here, if we specify the reading flow grid rows or reading flow grid columns, the order will follow it much more naturally in the visual manner. So you can test it out in Canary. It is put behind the flag, and it is a really interesting project to work on, where you can realize like the complexity of all the HTML and CSS properties and how they come together to make it easy to use for the end user, so that you only have to use one CSS property. Thank you.
All right, thank you.
All right, well, thank you. My name is Rob Paveza. I am an engineering manager at Microsoft, and I work on DevTools. So today I'm going to talk to you a little bit about what we're doing in source maps across Microsoft and Google. So, you might ask, why do we source map? And obviously, because we get this garbage in the JavaScript, and it's almost impossible to debug. So, what we end up seeing is that a super secret layout algorithm here. I think I took this out of Word Online as possible, just to try and think through. Okay, well, what is this going to look like? And the reason for this is because JavaScript is minified. Someone mentioned it earlier. We have large minified libraries out on the web everywhere. And at the end of the day, the question is, who can really debug that? So I want to talk to you a little bit primarily about what we've been doing at Microsoft for about 2 years and what we're now working to bring to Chromium. And that is a source map server. So at Microsoft, we have a product called Symbol Server. If you've debugged with C++, you've probably run into this, that you can store your PDBs online. And as soon as you get into a crash or something that you're trying to debug, you just go fetch the symbols from that. We've added the capability in Edge to be able to pull source maps from that as well. And we're currently working with the Chromium team to create a new extension API so that if you need to build a connected mechanism, maybe source map, or maybe Symbol Server isn't the right solution for you. Maybe you want to use a different kind of authentication or authorization mechanism. Maybe you want to store those source maps in some way. The main point here is today, we expect that your source maps are publicly accessible, and most people can run into those things. And we want to be able to enable you as a web developer to store your source maps in a way that not everyone can have access to them because they often contain source code, but that you can access them in production when you need to. Also, I want to shout out especially folks on the Chrome team like Simone Zend, who are working on source maps version 4. There are a lot of extensions to this that are important, most notably things that source maps version 3 don't support, like expression evaluation. One of the most critical points for this. It also allows you to see when code has been folded out. And then finally, we're calling this enhanced unminification, but it basically is going to allow language servers to jump in and provide this, even if you don't have source maps version 4 in your product yet. And this is what you get, at least in Edge today, looking at a performance trace. We think that this is far, far more debuggable using these source map extensions. So thank you.
Hey everyone, I am Kurt from Microsoft, and today I'm going to talk to you about some updates to text rendering on Windows. So for some background, when Edge switched from Edge HTML to Chromium, we got a bunch of reports from users that text looked harder to read. They said it was washed out or just not as bold as it was previously. And so last year I gave a talk at BlinkOn about some of the changes that we made to kind of address this. We experimented in Edge only with text rendering. And so there were 3 specific changes that we made in Edge only. The first is the text contrast formula in Skia. The second is Windows has this thing called the clear type tuner where you can configure how text is supposed to look. And previously Chrome would just ignore this value. And then third is the default value for contrast. So I'll give updates on all 3 of these. And so the first one is the alternate formula in Skia. We shared this with Skia, and we decided to just kind of remove it from Edge. It was removed a little while ago. Skia didn't want to replace their current algorithm, and we didn't want to maintain 2. So this is one less difference. The second one is the clear type tuner settings that I spoke about last year. I implemented them in Chromium upstream a few months later, and so this shipped in Chromium 1.24. It got some good press. People were excited about this. There were more articles than just that. But yeah, this was a good change to the platform, but it only impacts a small percentage of users. The biggest change is actually the default value for contrast. And so this one is actually going through stable experimentation. It's hitting 1% of stable this week, which is pretty exciting. It's already gone through Canary and Dev with not much positive or negative. So I'm very curious what's going to happen there. And so this is where those contrast and gamma values are stored. It's hard-coded constants, and you can see by the blame in the upper right corner that They haven't changed in about 10 years. And so you might wonder, how am I experimenting with this if it's hard-coded? Well, I'm actually doing it later in the pipeline, which I learned actually Skia caches the default value. And so with this new value, it's caching both. And the Edge lab actually found a 2K memory regression with this, which I was kind of surprised with. But I dug into the code and I actually found a savings of the exact 2K elsewhere. So I made an optimization in Skia and saved that. So now it's just a, it's bringing it back to the mean. And so, you're welcome to try this yourself. I have the features there if you want to try it. You can leave feedback in the CR bug. I also have a design document there, and you can also reach out directly. Wanted to thank a lot of folks at Google for this. So Dominic and David and Etienne all helped on the Chrome side. Few folks from Skia, and then also wanted to thank Ian, who kind of researched and pioneered all this in Edge. So thank you.
Hello, everyone. My name is Sam Davis from Microsoft, and I'll be presenting on CSS gap decorations. If you've ever struggled with styling spaces within CSS container layout, such as grid and flex boxes, you are not alone. As seen on Stack Overflow, this is a common problem that web authors face. See, the thing is that in web design, gaps in this layout are essential for layout aesthetics, but they're often not stylable and a source of great frustration for web authors. There are so many workarounds that web authors have to resort to, which includes position relative and having extra wrapper elements. I believe as a web platform engineer, one of our duties is to make the lives of web authors easier. And so we are introducing CSS gap decoration, which lets you style gaps in grids and flex boxes. From the web developer's point of view, you can vary the width, style, and color of decorations within gaps, just like in multi-column layouts. And you can also, these properties also support multiple values, like you can see. Also, if the T intersection is not pleasing for you, you can also avoid it using the outset property. In Blink, we're touching three major parts of the rendering pipeline: style, where we augment existing rule properties to account for this new syntax; layout, where we store and calculate the relevant layout information regarding the sizes and positions of gaps; and then in Paint, where we construct rects with this layout information and call the right paint ops. So for what's next is fragmentation, which is a case where a particular element cannot fit in the particular fragment, so we have to push it to the next fragment. In the case where gaps are fragmented, there's a break token in gaps. We want to ask ourselves the question, should gaps be fragmentable, not fragmentable, or half fragmentable? And also the paint order, which is in what layer should we paint these gaps, the foreground, the background, and the same layer as borders. The impact is that it obviously simplifies code and it opens up creative possibilities for web designers. As you can see on the GitHub issue, the BBC has commented that this would open possibility for their website. Thank you very much, and a huge shout out to Ian, Kevin, Alison, Kurt, and Ethan.
Okay, this is Antonio. I'm going to talk about the modularization of the Chrome browser directory. So a worth reading email for context is something that Eric Chen sent to to Chromium Dev mailing list, which is the design principles for desktop code in Chrome browser. Basically, it lists a couple of principles, and the full set of principles is actually available in docs/Chrome browser design principles MD. But we're going to talk about one of them, which we call modularity. So basically, it says that all features should be modular. It enforces the creation of API surfaces and splits the dependencies between them. Features should reside on their own directories, and each directory should have its own build.jn file. What do we have today? Talking about two particular directories, Chrome browser and Chrome browser UI. The first has 300 more or less directories, so 300 sub-features, and the other one has 87 subdirectories, so about 87 features, right? If we look at the build.jn files of each of them, They are actually huge, and they rule the compilation of all those modules. So basically, you're talking about 9,000 lines of code for one, 6,000 lines of code for the others, and that definitely goes against the modularity principle. So basically, the project consists in cleaning up those build systems by adding build system to each subdirectory that's considered a feature. Let's give an example. It's the code controls subdirectory. So basically, it has a circular dependency back with Chrome browser. And that's how it was declared before in the huge build.jn file, 4 files. And now that's how it looks with the modularized version. We basically have a API target because it has a circular dependence. And we have the implementation target, which contains the circular dependence back with Chrome browser target. What are the takeaways? Do not touch, if you can, the build.jn files that we are actually cleaning up. Circular dependencies, they are discouraged, but they are allowed temporarily, but they are supposed to go away when the major build.jn files are actually cleaned up. And the separation that we did with API and implementation targets, it could be reached with C++ if we do an interface and implement, the interfaces in the other target. In C++, we do it in GN. We do the work in a semi-automated way, in fact. So basically, we generate a skeleton of Vue.jn with one script. It looks like this at first run. Then we remove the previous references that it has in the other Vue.jn file. So it will look like this. We are removing. And then we actually construct the dependency list with another script. So we just add the construct list over there. We're tracking the work in a spreadsheet. So the green is what's done. The red is what's to be done. So there is still a lot of work to be done. And it's being primarily done by myself, Antonio, Maxime from Igalia, under the leadership of Eric Chen from Google. So that's it. Thank you.
All right, good afternoon. Hi, everyone. My name is James. Today I'll be sharing how a baseline and webstatus.dev can help us better track the progress of the web platform. These tools aim to provide valuable data and insights to help us achieve greater interoperability and build a better web together. As we all know, web interoperability is crucial. Users expect websites to work seamlessly across all browsers, but with features landing constantly, how can web developers ensure that they work across all website developers, ensure they work across all browsers? Baseline simplifies this by analyzing data from various sources like web platform tests, MDN, and others to provide a clear definition of interoperability. It categorizes features into 3 categories: limited availability, newly available, and widely available. This helps developers confidently use features knowing they won't cause compatibility issues. But how can we track the progress of features as they transition from limited availability to newly available? Webstatus.dev helps us answer that question. It ingests data from those same sources to provide a comprehensive view of the web platform landscape. The dashboard shows how a feature progresses from the different levels of availability. It identifies any discrepancies in implementation quality between browsers by looking at web platform test scores, and it tracks its overall trajectory towards becoming a stable part of the web platform. We're actively working to enhance webstatus.dev and make it even more useful to the web community. And here are some upcoming features, such as saved searches, so that you and your team can save and share your searches to quickly find information for you and your team. Feature usage, this is so you can track real-world adoption of your features, and global feature count, so you can compare feature implementation across different browsers to see the overall landscape. We've seen how baseline and webstatus.dev can help us track the web platform progress and create a more interoperable web. But to truly realize this vision, we need your help. So first ask, please attend the breakout session for a deeper dive tomorrow, so you can share your feedback and giving your opinions, so we can enhance these tools for the entire web community. Please take a look at these resources so you can learn more. And just, if you have any questions, feel free to reach out. And we hope that you join us in improving how we track the web platform to ensure a better web for everyone. Thank you.